Good morning, my dear students. How are you? Hope you all are fine. So let's start today's class. As I told you earlier also, fundamental theorem of arithmetic. Every composite number can be expressed as a product of prime numbers, and this factorization is unique for every number. Look at here. 6 is equal to 2 into 3. 6 is a composite number and the factors of 6 are 2 into 3 and they both are prime numbers. And this factorization is known as prime factorization also. Prime factorization you have done in your previous classes also. So I have given you the work for exercise 1.2, that question number 1, 2 and 3 you will do yourself only. So from today we will start from question number, I will start from question number 4. And question number 4 is that they are saying to you that given HCF of which number? HCF of 306 and 657 is equal to 9. And they are saying to you that find LCM. So how you will find? You know that we have done earlier also that HCF into LCM is equal to product of numbers. HCF into LCM is equal to the multiplication of HCF and LCM is always equal to the product of these two numbers. So let's start it. What we have given, what they are giving to us, HCF is 9. So we are keeping 9 in the place of HCF. LCM we have to calculate. Product of numbers, numbers are given 306 and 657 and they are product. Now they are saying for that LCM 9 is in multiply. When it comes here, it comes on divide. So 306 into 657 is divided by 9. Now you can calculate it yourself also. That LCM 306 into, first you will multiply, then you will divide it by 9, or you can divide it 9 first, or after that you can multiply. It's depend on you. So if suppose LCM will be given and they are asking for the HCF, the same procedure you will follow. Okay, that is the question number 4. They are saying to you that HCF is given, numbers are given, they are asking for the LCM. So what we have done, we know the formula that HCF into LCM is equal to product of numbers. And now we are keeping the value. HCF is given 9, LCM we have to calculate, and the numbers are given 306 and 657 and the product of these two numbers, and that is LCM 306 into 657 upon 9. So let's start the another question. And the calculation as in classroom you are doing, so in this time you also do yourself only. Now we will do the next question. They are asking in question number 5. In question number 5, they are asking to you explain why 7 into 11 into 13 plus 13, 7 into 11 into 13 plus 13, and the second number is 7 into 6 into 5 into 4 into 3 plus 5 are composite numbers. Why? Without calculation you have to explain that they are composite numbers. You know the definition of composite numbers, that every composite numbers are those who have more than 2 factors. As we know in prime numbers, the composite numbers are just reciprocal of prime numbers. Prime numbers have 2 factors, 1 or itself, and the composite numbers are those numbers who have more than 2 factors. So let's start it. So what we will do, see the first one, 7 into 11 into 13 plus 13. What we will do, see it clearly. 13, there are two terms, 7 into 11 into 13, and the second term is 13. So what we will do, we will take 13 as common. So what will remain? 7 into 11 plus 1. If we will see that this number has two factors now, 13 and this one, 13 and this one. So we can say that that number is not a prime number, this one is a composite number, because we are getting more than two factors of this number. Hope you get it. In the second part also, 7 into 6 into 5 into 4 into 3. First term is this and the second one is 5. 5 is common in both that. So what we will do, we will take 5 as a common. So what will remain? 7 into 6 into 4 into 3 plus 1. So it have one more factor, that is 5. So it proves us that they both are not prime numbers, they are composite numbers. Why they are composite? Because we get that one factor of that number is that only, the second one is 1, and the third one we have to count 5 and 13. In that part 5 and in this part 13. So it is proof that these numbers are not prime numbers, they are composite numbers. And why? Because they have more than two factors. Okay, now let's start the last one. The last one, the sixth question, fifth question of this exercise. That is the sixth one. Fifth question. In fifth question, they are asking to you, check whether 6 to the power n can end with digit 0. क्या 6 to the power n and with the digit 0? N can be any natural number, and they are saying to you n is a natural number, and natural number we know that 1, 2, 3, 4 up to so on. They are asking, is 6 to the power n will end with digit 0 or not? Means when we will open it, so at last the digit will come 0 or not. So let's check it. First we are taking n is equal to 1. 6 to the power 1 means 6. The second one, 6 to the power 2 means 6 into 6. What you will get? 36. 6 to the power 3. 6 into 6 into 6. 260. And up to so on. If we will check it, if we will open it, so we are getting 6 digit at the end. So then we will write that 0 will not end, 0 will not come at the end digit in the expansion of 6 to the power n. Okay, so that exercise is finished now. Exercise 1.2. Now that is your duty also, that you will do this exercise in your notebook, rough notebook. We are not saying that in fair, if you don't have fair, make rough notebook and do the questions on that only. And students are not sending me their works up to now. Some only 3-4 students have sent me their works. Send me work in my personal number. Don't send your maths work in the group only. Send me in my personal number. I hope you got it. So we will meet tomorrow again. Okay, all the best and do your work and stay in your home, stay safe.